Lesson 12.3 is about cylinders and cones. Okay, first let's look at cylinders. A right cylinder has two bases that are both circles and sides that are perpendicular to the bases, so they form a right angle with the base. And the lateral area is the entire area that does not include the two bases around the side of the cylinder. So if it was like a can of soup, it would be the area of the label. And it actually, if you were to take a can of soup and take off the label would be a rectangle, and it would have, its area would be base times height. So the lateral area of a cylinder is the distance around its base times the height, or in other words, the circumference times the height. So if we look at the base area, or the base circumference of a cylinder, the circle at the bottom, the circumference is 2 times pi times the radius, and the base, the area of the base, capital B in these formulas, is pi times the radius squared. So the lateral area is equal to the circumference, the distance around the base times the height, or 2 pi r times h. The total area, because there are two bases, is equal to the lateral area plus two base areas. And the base area is pi r squared. And then lastly, the volume is always a function of the base area and the height of the object. So it's base area times height, which of course base area is pi r squared. So it's pi r squared times the height of the cylinder. Okay, next is a cone. And a cone is a right object where the height of the object, the altitude from the vertex of the cone down to the base, is perpendicular. And a right triangle is formed by by putting together the height measured from the center of the base to the vertex of the cone, which is the pointy part on top. And between that line, a radius line, and the slant height, which is the length from the top of the cone, from the vertex of the cone down to the base edge. So that forms a right triangle, and because of that we can use all of our triangle information if we know two of those to find the third. But the base of a cone is a circle, just like a cylinder, so its circumference is 2 pi r, and its base area is pi r squared. So, much like a pyramid, a cone, the lateral area is 1/2 the distance around the bottom of the cone times the slant height. 1/2 circumference times slant height. And circumference, of course, is 2 pi r. So 1/2 of 2 pi r, well, when you multiply together the 1/2 and the 2, that's just a 1. So we end up with the lateral area being equal to pi times the radius times the slant height. The total area then is the lateral area plus the area of one base, so plus pi r squared. And the volume of the cone is much like, again, like a pyramid. It's 1/3 of the base area times the height. So again, that would be 1/3 of the base area, which is pi r squared, times the height. So those are the basic formulas for cylinders and cones. Okay, for our first example, let's find the lateral area, total area, and volume of a cylinder that has a radius of 10 and a height of 7. So I always recommend finding out the perimeter or circumference of the base and base area first. So the circumference of the base is 2 times pi times the radius. So in this case, it's 2 times pi times 10, or 20 pi units. The base area is pi r squared, so that is pi times 10 squared, pi times 10 squared, or 100 pi square units. Okay, so now on to the lateral area. The lateral area is circumference times height. So this is, as we recall, it's pi times r times the radius. Okay, once we've simplified it, so it's pi times the radius times, oops, made a mistake. Back to, again, lateral area is circumference times height, so it's 2 times pi times height. But circumference we've already figured out is 20 pi. So it's 20 pi times the height of 7, or 140 pi square units. The total area then is equal to the lateral area plus the area of a base. So in this case, it's lateral area of 140 pi units. Oops, another mistake. Lateral area plus 2 bases. So it's 140 pi plus 2 times the base area, and each base has an area of 100 pi square units. So it's 140 plus 200, or 340 pi square units. And lastly, the volume is the base area times the height of the cylinder, and we've already got the base area of 100 pi times the height of 7. So we get a base area of 700 pi, and that is, being volume three-dimensional, is in cubic units. So there's one example with a cylinder. Now for an example about a cone, finding the lateral area, total area, and volume of a cone. So I have a cone with a base radius of 9 and a height of 12. And I need to figure out L, what the slant height is. So I could use Pythagorean theorem, or I could see that this is a Pythagorean triple. 9 is 3 threes, 12 is 3 fours, so it's a 3, 4, 5. So lateral area is 3 fives, or 15. Not lateral area, sorry, slant height. Slant height is 15. Okay, so then I want to find the base area, and the base area is pi times the radius squared, or pi times 9 squared, or 81 pi. Okay, now I'm ready to look at my formulas. The lateral area of a cone is 1/2 the distance around the bottom times the slant height. And when we simplify this formula, it's pi times the radius times the slant height. So in this example, it's going to be pi times the radius of 9 times the slant height of 15. And so that is 135 square units. I'm sorry, 135 pi square units. Then total area is the lateral area of 135 pi square units plus one base area of 81 pi square units. So altogether that is 216 pi square units. Okay, and then lastly the volume. The volume is 1/3 the base area times the height. So in this example it would be 1/3 of 81 pi times the height of 12. So 1/3 of 81 is 27 times 12. I would get 324, and this is going to be in cubic units. I'm sorry. 324 pi cubic units. Okay, and so that's working with a cone. Okay, this last example involves a cylinder and a cone. I'm going to pretend that I'm going to take a solid metal cylinder that has a radius of 4 and a height of 3, and I'm going to melt it down and recast it as a cone of solid metal with a radius of 2 and an unknown height. I want to know, when I recast this into the cone, what's the height going to be? Now obviously the height's going to be a lot taller than 3. The radius is smaller, and I've got the same amount of metal, but I am casting it into a cone that has a volume that's less than a cylinder of the same radius and height. So anyway, let's look at, this is basically a case where I'm going to set volume of the cylinder equal to volume of the cone. And the volume of the cylinder is known. For the cylinder, the volume is going to be the base area times the height, which is pi times the radius squared times the height, which in this case is pi times 4 squared times 3, or 16 times 3, 48 pi cubic units. Now, when that gets recast, that 48 pi, that volume of 48 pi cubic units is going to result in a cone that has a volume of 1/3 its base area times its height. So that 48 pi will equal 1/3 of pi r squared. So in this case of pi times 2 squared times the unknown height. So height is the variable I'm going to solve for. So continuing to simplify, 48 pi is equal to 2 squared is 4, so 4/3 pi times the height. Okay, so both sides I can divide by pi, and I can multiply both sides by 3/4, which is the same as dividing by 4/3. And I get that height is equal to 36 units, which should make sense. That when I recast that as a cone, the cone had to get really tall. So that's it for cylinders and cones.